Hi, welcome back to Meteorology 101. Visit my website, meteorology101.com, and get your head in the clouds. So, this video I'm going to talk about the winter storm that's going through. And we'll pull up a couple of charts to see what's going on. We'll pull up some models and see how all this plays out. So, up to the north over Ohio, from Pennsylvania, Ohio, all the way to Indiana, stretching all the way back to Illinois and to Missouri, we have a big snow band. We have a freezing snow band from southern Ohio, all the way from West Virginia through southern Ohio, right along southern Indiana, shooting all the way back down into Oklahoma. And then everything to the south of that is rain, maybe some scattered frozen precipitation over Nebraska, Kansas, over in them areas. So we see the radar just kind of picking up some reflection through a lot of the northern U.S. So if that's actually hitting the ground, that's kind of questionable there. But we're definitely getting snow and a moderate to heavy snowfall. We were getting in southern Ohio and getting some pretty bad, slick freezing rain and mixture over northern Kentucky. So I'm going to go pull the surface charts. I'm going to pull a thickness chart first. We're going to look at where that 540 line is. See where our rain snow line is, and then we can pretty much judge how accurate these charts are versus that radar. And then when we pull the models, we can have a pretty good idea how the models are initializing. So I'm going to pull a thickness chart. Here comes the thickness chart. First thing we're going to look at on the thickness chart is that 540 line. That's going to be our rain snow line. So this data can be a little bit older because this data is only downloaded every 6 hours. So it can be a few hours old at sometimes. This is like 22 to 23Z, which that's about 7 o'clock. 6 o'clock, so we're about an hour behind on these charts. So a little bit of that can change as this air mass modifies. We've got high pressure to the north, that's pushing south, and then we have that inverted trough is still over the Ohio Valley, stretching all the way up into Ohio. It looks like it deepened a little bit further north, and then warm air advection. These are just thickness lines, so we don't see the temperature yet. I'll pull up a surface, we'll look at the temperature. We got a lot of warm air advection to the south and pushing that warm, moist air up over that cold, deep, cold air mass, and then just causing all this snow. As it reaches saturation, it falls through the high pressure system, which is a frozen air mass below freezing, and then most of that falls as snow. So the first thing we're looking for is this 540 line. So if you see that it is off the east coast, let me see if I can get up a drawing. Alright, let's do some drawing on this for a minute here and see what, let's just draw out that line. Let's trace it out with the purple. So it stretches into northern Virginia, straight through the center of West Virginia, southern Ohio, southern Indiana, Illinois, northern Missouri, northeast Kansas, southeast Nebraska, and then all the way up to the west coast. So that is our rain snow line. Anything to the north of that should be snow. Anything to the south of that should be rain. And then anything along that line, or just a little on either side of that line, really can be is that mixed precipitation. So if you remember on the radar, most of this right there at southern Ohio, so this is pretty accurate on that mixture. We were getting that mixture at southern Ohio, and then down in Kentucky, all that being look like a mixture, and then starting to get rain down in the Tennessee. So we got a lot of mist being reported, IFR conditions in the central United States through the plains, and then ridging off that high pressure system. So this being upside down, if you look at the troughing at and ahead of the trough, all the way to the ridge, that's where you'll have any moisture precipitation in between those two. And then we have the ridging off the east coast, and then we still have warm air advection we have a southerly wind right there, southerly here, and then that's pushing moisture up over this high pressure cold air mass, and then most of that is just snow to the north. But if you look at a couple things here, here's a wind from the southeast, one from the northwest, from the north, from the south. Let's pull some of these up. Let's just mark some of these here so we can get a good picture of what's going on. You look at that low level convergence. This is all on the surface. So you have all this convergence in this area with a warm moist air mass and then a cold dry air mass. And then that warm moist air is less dense than that cold air mass, so it just rides over top of it, and that's what's causing all this precipitation to the north. So we do have snow. Let's see, mark them all blue here. This is all snow to the north. We've seen that all on the radar. We've seen all this green was, most of this green right here was mixture, and then a little bit of rain to the south. So I'm going to go ahead and erase this, and then we'll pull up our surface chart. The surface chart, the only really difference there is going to be we're still going to have the same isobars. We're going to still, but we're going to show the isotherms where we show that warm air advection from the south. That's the warm moist air. It's going to be pushing up over this air mass. So we still do the station plots. And still the same thing. We got the southerly winds versus the northerly winds. Let me get you back over there. Alright, so right there, all your southerly, then your northerly. Now you're looking at all that convergence right there. Same thing what we're looking for. So let's let this program play some fronts, and then we can get an idea where our frontal systems are. And then high and low pressures, we know this is a high. That's an Arctic air mass. It's got 3 degrees, -3, -13 right there in Canada, 19 over Illinois, 28 over, looks like eastern Ohio, or that's actually over West Virginia. And then we got a lot of mist being reported. It looks like low visibility to the south. That's that bridging. Stable environment. That's what's causing all that mist. Maybe, getting to the point almost to being fog. Dropping visibility with all that moisture and just capping that moisture to the surface and just causing the mist, causing low visibilities. So now we get the fronts. Basically what I look for here is just one, the temperature differences, the wind shifts, dew point differences, and we can place those fronts, and then all that warm air advection up ahead of this warm front. And then you're looking for any, we'll go up into the upper levels, look at the 500 millibar, look for the vorticity chart, and if this front just kind of sits there and becomes almost stationary, which it basically will, then you can actually get a low pressure system built along that front if you have upper level divergence, and then that low pressure system develop and then push to the northeast, and then that could just cause even more warm air advection from the south, pushing over this cold air mass and just causing all kind of precipitation. I mean, that's essentially what's going on, except we don't have like a clear developed low pressure system over the east coast there. So this could be a lot worse, but we are getting that warm moist air being pushed aloft, and I think that's why we're getting a lot more accumulations than the Weather Channel and everybody's saying what they're all calling for. So let's go look at we'll go pull up a 500 millibar chart real quick, and then we're going to get out of this and go to look at these forecast models. The models have been handling these systems pretty good, so we'll just see how all this plays out. And then I think we got a couple more systems coming through, one for the weekend and then maybe one for early next week. So Monday, Sunday and Monday, like Sunday morning low about 8 degrees in southern Ohio. Then it'll be a high of 14 on Sunday, and then low of 3 and a high of 22. Then we're getting back up into the lows of the teens, and then pushing up toward the 30s for Tuesday and Wednesday. So if you want to forecast for your area, hey, just make a comment, say, hey, I'm from here, and then I'll just give you a general forecast for that area, just for the fun of it. You can at least know if you're going to get rained on or snow or all that stuff. If you're doing anything, any critical activity that depends on the weather, then refer to your professionals. I was a professional at one point. I was in the United States Marine Corps as a weather forecaster, did it for a couple of years, so I'm pretty good at pinpoint location forecasts. Lots changed since I did that, and I'm a little rusty, so I'm not going to be perfect every time. But throw your city out there, and we'll see what we can do. So I'm going to go to the 500 real quick just to get an idea of what's going on in the upper levels. This might get a little crazy because I already have a lot of color on this chart, and then I'm going to throw more color on top of that. So I don't really see anything significant. We might have a positive vorticity advection over western Missouri, eastern Kansas. That's an indication of upward vertical motion. So with the high pressure system there, maybe we have an upper level trough moving through. That's causing a lot of the lift in these upper levels with this moisture too. We'd have to go look at upper level charts. It takes so much time. I get way deep into these charts, and then next thing you know, we're an hour in. So I'm going to kind of leave that alone, and we're just going to go after the models a little bit tonight and see what we got. So one more thing I'll throw on this chart is I'll throw the vorticity readings on here so you can see where that positive vorticity is. So let me pull up, let me just do some drawing real quick. If you see this X right here, that is positive vorticity, upward vertical motion. Now with the winds going into that direction, now we can take this positive vorticity and we can take it right there and say that is positive vorticity advection. That's why this chart puts that color right there. Same thing over here. Up to the north, it looks like we have that positive vorticity, and then with the winds, then we can have positive vorticity advection ahead of that. So that just shows you what this chart does. And then anywhere we have that positive vorticity advection, we can have upward vertical motion. So anywhere you get the upward vertical motion, that's where you can get those. If you have this instability, the precipitation region, you need that lift, you can pretty much say that area is going to be the areas of lift. Now if you have a vorticity advection over a front, so basically if a stationary front came through here, we had a stationary front there and you had that upward vertical motion, indication of upper level divergence over that frontal system, then you can start getting warm air advection from the south, cold air advection from the north, and then you get your rotation. Now you can get a low pressure system form along that front, and then that's when you have the warm front, cold front, and then that system develops and then starts moving to the northeast. It follows the mid areas of so then that system develops and pushes off to the northeast. And then you have, depending on your steering flow, your mid-level steering flow, what direction it's actually going to go, but you get just a low pressure system developed right over there, and then depending on the jet stream, there's a lot to that. So we'll get into those details in other videos. Right now, we're going to go over to our models, and then we're going to see what we got. Tropical Tidbits, pretty good one. This is the easy one to use. Just a push of a button, you can go drive this to the next chart and then see how this thing kind of plays. I mean, for initialization, if we pull up our radar again real quick, so we got the snowfall all the way through the north, just below the Great Lakes region, south of the Great Lakes. Then the mixture stretching all the way from West Virginia and southern Ohio, Illinois, all the way down into Arkansas. So if we go back to our chart, our models, that's pretty much what we're showing, all the way down into Arkansas with the mixture, southern Ohio, southern Indiana, and then south of the Great Lakes region, we got that snow. Let's see, we got, I'm just going to go back and look at the radar. I don't think you can see it just yet, but that's pretty close. I mean, so if we follow this chart out, now this is valid 06Z, like 1 o'clock in the morning for Thursday. And 12Z, 7 o'clock in the morning, so every 6 hours. This chart is progressing every 6 hours, so we got that. Actually, look at that mixture stretching down into Arkansas, but now it just gets even stronger and shoots all the way down into northeast Texas. So, and then that snow still presses off through the Ohio Valley, and then Pennsylvania is clouded in looks like Jersey, and then it starts shooting off the East Coast. So snowfall all the way through, mixture just hanging in there, and then it just disappears after when that 6 hours for the 18Z Friday to 18Z Thursday to 0Z Friday. So till about 7 o'clock in the evening Friday, then it just, that's gone, all the frozen precip. And then looks like you got a little bit over there in Virginia, a little spot, and then the mountain area, the snow, and then everything to the south is going to be rain. So what we're looking for is any low pressure developments. If this thing's going to pick up any low pressure development, there's a low pressure way down there over Mexico. You got your ridging coming in from the high pressure to the northwest, out of the north, that's pushing south, and it looks like it's giving some more lift with some moisture in the Great Lakes region over mid-Wisconsin right there, and then the Great Lakes region, and then rain all to the south. Looks like some troughing in the south causing all that lift from the over the Gulf of Mexico. Still snowfall all through the central United States there from that high pressure pushing in, just ridging in, and then now we got some frozen precipitation moving up through, looks like Virginia, and then this thing all along the East Coast. Once it gets up to the north, then it becomes mixed, and then we have snow over Pennsylvania and northern Ohio, and then a lot of mixture over Virginia again, pretty much in the mountains, and then the snowfall over Pennsylvania, northern Ohio, and then that system pushing out. So you see that jump right there. There's over the Ohio Valley. It just kind of jumps over the Ohio Valley. Though probably Ohio Valley could probably see a little bit of snowfall right between those two periods right there, which is Saturday night, Saturday afternoon, and the Saturday night. It kind of jumps. So actually it's in the Sunday morning, 06Z. That one there is to the west of northern Ohio. That's at 0Z. So the 7 o'clock in the evening, and then 1 o'clock in the morning, that's when it jumps. So between that time, you could probably get a little bit of just a dusting or something going on there. So I'm looking at this low pressure system over the four corners. keep an eye on that thing. It doesn't really have the low pressure system moving much. It's dropped to the south, but we do have some troughing off the lee side of the mountains, and then some significant snowfall over northern Texas Panhandle, Oklahoma Panhandle, and then Kansas. So that's a pretty good system starting right there, and then some mixture well to the south over Arkansas and Louisiana. So, and that continues to push south. Snowfall all through Texas, mixture all the way to the Gulf Coast. That's pretty significant. That high pressure just ridging in, that cold air pushing through. And this is Monday, February 15th at 7 o'clock in the morning. And then we have another line that's all developed all the way across. Pretty much the same thing what we've been running into is this warm air advection from the south pushing over that cold Arctic air over the Ohio Valley and just stretching all the way back down into Texas. So we could get another pretty good snowfall there. But Texas, Oklahoma, Arkansas, looks like a heavy snowfall. I mean, a pretty moderate snowfall there over those states. So they could definitely see some moderate accumulation. Have to keep an eye on that thing. See how intense this gets. If these models are weaker than what they have been, showing been on the weak side like they have been, then they could get some real significant snowfall. Now you got that low pressure system developed right there. It just pops up right over, looks like Alabama, becomes a closed low, and then just to the north of that with the mixture, and then further north all the way up into Missouri, and then southern Ohio, Indiana, Illinois. I mean, you're getting some pretty good, that's all snow. So now Arkansas looking like maybe some heavy snow there. I mean, that's 4 to 6. Now we got a system that's developed pretty good. So this is out to Tuesday, February 16th. This is 1 o'clock Tuesday morning. Now we got some serious wraparound moisture overriding that high pressure system. If this thing holds true, it's 132 hours out. So we could definitely see some heavy snow, major accumulation in the Ohio Valley region. So push that on through, and then go into the northeast, and it looks like here's the thing that hurts you. I don't mind the snow so much, it's the ice. If you look at these areas of icing, there's some icing right there, southern Ohio, Kentucky, all through Kentucky, down into Tennessee. Then that low pressure pushing north, and then southern Pennsylvania, eastern Ohio, and then over the mountains, getting some pretty good mixture. But now if you get this thing pushes up to the northeast, then eastern Pennsylvania, all of our favorite states up there are getting clobbered with ice. So that could cause some significant power outages if you get a good ice accumulation, because that ice gets pretty heavy pretty quick and will bring down power lines. So now we're looking on the lee side of the mountains over here. We've still got another snow system going on. Looks like ridging out of the north. That high pressure just kind of hanging out up there, ridging to the south, and then any warm moist air just over pushing that cold air mass, just becoming snow. And then that looks like another little band of snowfall pushing through Iowa, Illinois. Alright, now what do we got here? Another low pressure system developing over the Gulf. These are the ones we gotta watch out for. Let me go back real quick, see what this one is. This low pressure system did kind of just all of a sudden appear. This looks like it's developing out over the Gulf. That's where that thing develops over that. That's where you pick up all that moisture and just bring it north. And then you shoot over that high pressure system, that shallow cold air mass, and it just drops through the cold freezing air, and then it's all snow. So look, get back to that next system, another low pressure system right there over the Gulf Coast, and then shooting over the foot of Louisiana, and then up to the northeast again. I mean, we could get this thing could get 1993 all over again. Where it looks like we're getting a lot of rain along the mountain range and then to the east of that, and then that low pressure system being over Ohio. What did I just do? Hit the home button. So, right there over eastern Ohio, getting that wraparound moisture and then getting some significant snowfall there. So, like I said, these jump 6 hours. So, from 6Z on the 19th, that's next Friday, to 12Z, you got the wraparound moisture. That could be significant snowfall for Indiana and Ohio, and Kentucky, the whole tri-state area. So, and then that's a pretty intense low pressure system shooting over the Great Lakes region. Alright, so, and then you got high pressure just dominating the East Coast, and that's what we want. Well, I mean, that's just going to be a cold air mass that is just going to keep that snow around for a while. It's not going to melt, but it's going to clear things out. So, the only issue with that is in the evening, if you don't have any clouds, then you got all that radiation from the Earth being emitted. That's going straight out to space. There's no greenhouse effect to keep you warm at night. But you do have snow on the ground, so it gives you a little insulation. That's a plus. I'd rather have the snow than the ice. We do got some snow right here. This is Saturday, 18Z. And that's about 1 o'clock in the afternoon. And you're looking at the Ohio Valley, the tri-state region once again, just getting some light snowfall. And like I said, all this stuff can change. I mean, this is pretty far out now. So, but the high pressure just dominating the East Coast at that point. And then we got, what's this, a clipper or something coming through, a low pressure system to the north. And now it looks like a frontal boundary. And then that's causing some lift and giving us some precipitation all through, right back through the Ohio Valley, giving us rain. Depending on what the temperatures are going to be at this time. Let's go look real quick and see if this will pull something up. I don't know. I don't think this thing will. I tried this last time. Tried to get a some SCOOT data, forecasted SCOOT data, see what that surface temperature was going to be, but I don't have. It's not going to come up on this. So then the frontal boundary just pushing through, and then looks like that clipper just coming down, and then another low pressure system dropping down out of Canada. And then that's just picking up moisture, wrapping it around the northern part of that low pressure system, and could actually get some more snowfall in the Ohio Valley. We'll have to keep an eye on this thing too. So, winds out of the northeast, that's considered a nor'easter. So that drops down out of Canada and crosses the United States, causes some snowfall through the Ohio Valley, all the way up into Pennsylvania, through the mountain ranges, and then shooting up to the north, to the East Coast, just off the East Coast over the Atlantic. So I'll pick up any of that moisture off of the ocean, and then that's where all them systems really explode out there. So, alright, that's pretty much it. This is 384 hours out. That is a couple weeks, and take all that with a grain of salt. Low pressure system. This is the one we need to look out for. This is on the 19th. This is next Friday. That could change quite a bit too. Well, this is the other one. So that was the system before that. Now this is Tuesday. So that's only 6 days away. So this is the one we need to watch out for. This thing could be, if it's really that intense, I mean, it ain't really that super intense. 1,005 millibar low. Okay, I mean, that's fair enough. I mean, picking up that moisture from the south, right there over the Gulf, bringing that moisture up, that's definitely something to keep an eye on. So we'll watch that as it develops, and I'm gonna go ahead and end this video here. These things get pretty long if I keep talking. So do me a favor, give me a thumbs up, like my channel, subscribe, and visit Meteorology 101 for some major weather detail. If you have any questions on that page, I'm not sure if I have a contact page on there or not. I'll check. If you're interested in one, leave a comment here, and I'll put a comment page on the website, and then we can go into some deeper discussion on weather if you like. So thank you for watching and have a great night.